everyone, and thank you for the opportunity to present smart electrical isolated power supply systems for critical care areas. Before I begin, I would like to introduce myself. My name is Kotenko, and I'm a solutions manager at M-Control. In my presentation, I will cover the following topics. I will provide a brief overview for electrical safety in patient's area. Then I will talk about isolated electrical supply systems. And then I will introduce smart isolated power supply systems. And finally, we have a demo case with us, so you can see how smart isolated power supply system works. Okay, let's get started. Electrical safety in patient areas. The presence of patients in settings like intensive care units or operating rooms make this environment extremely challenging for ensuring electrical safety for patient and medical personnel, and at the same time maintaining power supply for critical medical systems. Patients in ICUs or intensive care units are extremely vulnerable to electrical hazards, particularly to electric shock, because their condition, they could have compromised physiological condition. They could be sedated, they could be under anesthesia, or they could be critically ill. And obviously, they cannot respond to electric shock in the same way as a person under normal physiological condition. Surgical incisions, wounds, burns, skin damage can significantly reduce body impedance. And in case of in the event of electric shock, it will result in increased body currents and can lead to critical or serious injury or death. Tubes, IV lines, catheters, they can provide direct pathway to internal organs, increasing the risk of, again, serious injuries or death, even from very small leakage current. And we shouldn't forget about medical gases, disinfectants, and other highly flammable substances commonly found in intensive care units or ICUs, where electrical fault can result in a spark or excessive heat, increasing the risk of fire or explosion. But on the other hand, intensive care units and operating rooms, they're heavily dependent on a wide range of medical equipment. Systems like life support systems, surgical instruments, patient monitoring systems, they must remain operational because any power interruption can lead to, again, it can jeopardize patient safety and affect clinical outcomes. And for all these reasons, we need a solution that can provide the highest level of protection to patients and medical personnel against electrical hazards, and at the same time to maintain power availability to critical medical systems even under fault condition. As we know, AS3003 standard specifies requirement to electrical installations in patient areas. The standard mandates the use of leakage protective devices in cardiac protected and body protected electrical area, and recognize two types: residual current detection device type 1 and low voltage isolation transformer. I hope we can all agree that between these two solutions, only isolation transformer can provide the highest level of electrical safety while maintaining power availability for critical medical systems under fault condition. If some of you have a different view, we have a separate presentation explaining the difference between these two approaches. Electrical supply, isolated supply system. As we know, Australian Standard 4510 sets out requirement to isolated electrical supply systems. But I would like to point out that this standard was published in 1999, 27 years ago. And what it means that all isolated electrical supply system used across Australian hospitals today are based on requirements developed almost 30 years ago. There is no doubt that this system provides all function efficiently, but what the system lacks is intelligence. Intelligence which is required or expected today from modern and smart healthcare environment. And let me show you why. The key component of any isolated electrical supply system is isolation transformer that provides galvanic separation from hospital element system and create system with floating earth on secondary side. The second important or key component of isolated electrical supply system is line isolation monitor that provide continuous monitoring of prospective hazard current and triggers alarm when the current exceeds the preset value. Overload monitoring is another essential function that provide monitoring of load of isolation transformer and triggers alarm when load current exceeds rating of isolation transformer. And also this system can include optional remote alarm panel to provide audible and visual alarm triggered by line isolation monitor. Let's use as an example a typical operating room protected by isolated electrical supply system. One isolated electrical supply system can provide power up to 12 pieces of medical equipment. And let's imagine a situation we have a surgical procedure in a progress and everything is going well. All 12 pieces of medical equipment operating normally, line isolation monitor power distribution, power system for potential hazards and faults. And surgical procedure is progressing well until suddenly prospective hazard current alarm triggered by line isolation monitor. And this is where the challenge begins. Line isolation monitor tells us that there is a problem in operating room, but what it doesn't tell us where the fault is. And identifying the fault between 12 pieces of medical equipment would be quite difficult, and as you can imagine, can be quite stressful task for medical personnel. Instead of focusing on medical procedure, medical personnel need to guess which particular piece of medical equipment has insulation fault or earth fault and make a decision which device they should disconnect first. Similar scenario happens when line isolation monitor trigger overload alarm. What it means that isolation transformer is overloaded. But again, line isolation monitor doesn't tell us which piece of medical equipment is responsible for excessive current. And it's up to medical personnel again to figure out which particular piece of medical equipment is responsible for excessive current. So I think you can agree that we cannot call this system intelligent, but luckily there is technology available that can make this system smart. And let me show you how smart isolated power supply system works. In order to comply with AS 4510, smart isolated electrical supply system also provide line isolation monitoring and the overload monitoring, but they also provide current monitoring of each individual circuit and automated earth fault location. And instead of optional alarm panel, smart isolated electrical supply system include information panel. Let's go back to our operating room, which is now protected by a smart isolated electrical supply system. And again, the same scenario where in the middle of a surgical procedure, and everything goes well until we hear prospective hazard current alarm triggered by line installation monitor. And line installation monitor, again, it will trigger alarm in order to comply with AS 4510. So, but on information panel, you will see not just alarm, but it will provide a meaningful description of the nature of the alarm. And a moment later, EDS system will automatically detect circuit which is responsible for high prospective hazard current. And it will display all information on information panel, so you know exactly which circuit is responsible for alarm. And then also you can provide instruction to medical personnel what to do. Should you contact technical department or you can disconnect this piece of equipment. And similar response, smart isolated electrical supply system provide on overload alarm. Current monitoring system can detect which particular circuit is responsible for excessive current and provide information about fault on information panel. And again, this case medical personnel, so they know, yes, we have fault in the system, and we know exactly which particular piece of medical equipment is responsible, and then they can make a decision, informed decision what to do. This table provides a comparison between traditional or conventional isolated electrical supply systems and smart isolated electrical supply systems. As you can see, traditional isolated electrical supply systems provide very basic monitoring functions. Yeah, they monitor total prospective hazard current and total load current. But smart isolated electrical supply system, in addition to this main total prospective hazard current and total load current, it also monitor load current and prospective hazard current on a power point or circuit outlet level. And traditional isolated electrical supply systems, they have very basic alarm function. Yeah, so they provide only audible and visual alarm on prospective hazard current or on overload condition. But smart isolated electrical supply system will tell you exactly which circuit has fault, either and is responsible for overcurrent or high prospective hazard current. And just a few slides to explain you how EDS works. So EDS stands for Earth fault detection. We know that Earth fault is responsible for an increase in prospective hazard current. So what happens if we have Earth fault in the system? It will result in increase of prospective hazard current, and line installation monitor will detect it and triggers alarm. And then line installation monitor will go in EDS mode. In EDS mode, it injects Earth fault locating current. And this current, you see dashed line, it will go back to line installation monitor via Earth fault. And because EDS use current core balance current transformers, they will detect this Earth fault locating current and send information to information panel that current is detected on circuit number 10. And this technology is not new. It's been around for almost 20 years and been successfully implemented in hundreds and hundreds of hospitals around the world. This is a list of hospitals. You can see names, cities, and countries, and more hospitals and more hospitals. But this map provides a better visual understanding where in the world this system are used. As you can see, Southeast Asia, European countries, USA, Canada, and many countries in South America. But unfortunately, we don't have any installation in Australia yet. And as I mentioned before, we have a demo case. So if you want to see how our system works, please come over here and I would be happy to demonstrate it.